Hi everyone, how are you all? So now today's named reaction is haloform reaction, which is very important. So it will somewhat lengthy video, but I will cover complete haloform reaction. So different types of example, what are the exceptions which are involved in haloform reaction? So which type of compounds will participate in haloform reaction? And what is the mechanism of haloform reaction? How many moles of halogens are involved here? So, and what is the rate of reaction? Rate will depends on which factor. Those all I am going to explain in this haloform reaction. So don't waste the time. Then let's get into the video. So we'll see the haloform reaction. What is haloform reaction here? The carbonyl compounds with at least one methyl group. Carbonyl carbon attached with methyl group. So such type of compounds only participate in haloform reaction. This is also not 100%, only in case of 95% only. Without this functional group also some compound, 5% of compounds will participate in haloform reaction. Those all we will see here. Now this compound, carbonyl compounds with carbonyl carbon, adjacent carbon should be what? CH3 carbon. Then only it participate in haloform reaction. And also if you have taken the alcohols, so CH3, CH2OH, that alcoholic carbon, adjacent carbon should be, this is functional group carbon. The functional group carbon, adjacent carbon is called what? Alpha carbon. That alpha methyl alcohols also participate in haloform reaction. This is functional group adjacent carbon is called alpha carbon. Alpha carbon should be what? Methyl group. Okay, na? Alpha methyl keto groups, alpha methyl carbonyl compound or alpha methyl alcoholic groups will participate in haloform reaction. Now in haloform reaction what happens? What are the products we are going to get means when it is react with halogen. Okay, now we have different types of halogens. We have chlorine, bromine, iodine and fluorine. Now if halogen, that is chlorine, is react with these functional groups, then we will get the what? Chloroform. What is chloroform here? CHCl3 is called chloroform. This chloroform is a colorless liquid with a pleasant smell, which is also used as anesthesia. Okay, na? So pleasant smell it has. Now CHBr3, it is called what? Bromoform. Okay, na? So it is called bromoform, it is called iodoform, it is called fluoroform. Now this is bromoform. Bromoform is also colorless liquid with a sweet smelling and also light yellow color it will be. And we have the what? Next one, that is iodoform, which is very important. So this iodoform has the antiseptic nature. Okay, na? So whenever you are playing outside in an ground, so in school level or in college level, whatever the competitions, if you are participating, when you fell down in the ground, what they will do? First they will clean the wound with hydrogen peroxide and they will apply this iodoform solution. This iodoform solution will has the what? Antiseptic nature. So the antiseptic nature of iodoform is not due to the iodoform itself. This iodoform releases the iodine. That iodine dissolved in the alcoholic solution, that iodine will have the antiseptic nature, not iodoform itself. Is that clear? So that is very important one. So iodoform will have the what? Pale yellow crystalline solid. Iodoform is what? It is a pale yellow crystalline solid which forms the what? Yellow precipitate and with a hospital like smell. And whenever we go to the hospitals, we'll get some smell no there. So such type of smell it has the iodoform, which is very important, which is used as antiseptic. Now next we are going to see the fluoroform. That fluoroform is not formed, okay, because it is an highly unstable one. It is an highly unstable. It is not possible to prepare this fluoroform. Is that clear? So now next we are going to see here what type of, how that reaction takes place in haloform reaction. First we will see the one reaction. Now you take the what? Aldehyde, acetaldehyde. When it is react with halogen, so in presence of alkali, that is sodium hydroxide or potassium hydroxide, then we are going to get this CH3 group is there. No, this CH3 group is converted to haloform. That is CHX3 will get. And this carbonyl carbon will be oxidized to HC double bond O, ONA. Sodium salt of carboxylic acid will get. Along with that, we are getting 3 moles of water. Okay, so along with this, we are getting the water 5 moles of sodium halide. Okay, na? So we have to take the 6 moles of NaOH here, 3 moles of I2. Now you see here, so here 3 halogens, here also 3 halogens. Sorry, you have to take the 4 moles of NaOH, 3 moles of halogen, then we are getting 3 moles of halide here, 3 moles of sodium halide we are getting. Okay, so in detail in mechanism we will see how we are going to get that 3 moles of water and 3 moles of sodium halide, how it will be eliminated from the reaction we will see. So we will take the simple example, that is acetaldehyde. When it is react with iodoform, 3 moles of I2 plus 4 moles of sodium hydroxide. So then what happens? We are going to get CHI3, that is iodoform, which is what? A yellow colored crystalline solid. So it is an yellow precipitate will be formed. So now this yellow colored solid, whenever we are getting that one, so which indicates that what? Carbonyl carbon adjacent we have the what? One methyl group. Okay, na? So by using this iodoform reaction, we can separate the 2-pentanone and 3-pentanone. 2-pentanone gives the positive test of iodoform, but whereas 3-pentanone will not give. I will tell you. So along with this, we are going to get 3 moles of water plus 3 moles of sodium iodide. Now you take, for example, we have, this is 2-pentanone. It is what? 2-pentanone. This 2-pentanone and 3-pentanone. We have, this is 3-pentanone. 2-pentanone and 3-pentanone. So this 2-pentanone contains the CH3 group. Carbonyl carbon adjacent we have CH3. But whereas this 3-pentanone carbonyl carbon, we have the CH2 carbons. These two are CH2 carbon. So these not participate in iodoform reaction. But whereas this 2-pentanone participate in iodoform reaction, will get the yellow crystalline solid with iodine. Is that clear? So which gives the positive test with iodoform, but whereas 3-pentanone cannot be given. So which is somewhat, which is one of the important question which is asked in repeated examinations. Okay, na? So this 2-pentanone and 3-pentanones are separated by iodoform reaction. Now which type of compounds participate in iodoform reaction, which does not participate? We will see the list of examples now. Examples, which type of compounds will participate in haloform reaction, we will see. Just now I told you the compounds which have CH3C double bond O group, that is carbonyl carbon, adjacent carbon should be what? CH3 carbon, and also that is carbonyl functional group, adjacent carbon is called alpha carbon, that is alpha methyl carbonyl compounds participate in haloform reaction, as well as the alpha methyl alcohol will participate in haloform reaction. This is what? Carbonyl, this is functional group attached carbon, adjacent carbon is called alpha carbon. That alpha carbon, alpha methyl group containing alcoholic functional groups also participate in haloform reaction. So which is only in case of around 95% it will be correct. In very few cases, those exceptions I will explain in the later. Now you see in this case, this is a acetaldehyde which contains the CH3 group, so it participates in haloform reaction. Now you see this is a alpha carbon, this is CH2, so which does not participate in haloform reaction. It should be CH3. Now in this case also carbonyl carbon adjacent we have CH2 not participate in haloform reaction. Now this is carbonyl carbon, this is alpha carbon, so it is not having the CH3. Benzaldehyde not participate in alpha halogenation, that is haloform reaction. Now this is carbonyl carbon, it is a acetophenone which contains alpha CH3 group, so it participate in haloform reaction. Now we are going to get this. Here also this acetone contains the 2 alpha methyl groups. So this alpha methyl group contains, so it participate in haloform reaction. This is which one? 3-pentanone. Just now I explained you know. So it is a 3-pentanone does not participate because it is alpha position contain CH2 group. So it does not participate in haloform reaction, which is very important. So this is a 2-pentanone which contains CH3 functional group, so which participate in haloform reaction. We have to check beside the functional group, it should be methyl group. So carbonyl compound adjacent carbon should be CH3 carbon, then only it participate in haloform reaction. Now you see in this case these two are alpha carbon which is not having the alpha methyl group, so it will not participate in haloform reaction. It is a benzophenone, will not participate. So formaldehyde also not participate. Now that is what in case of carbonyl compound. We will see some example in case of alcohols. What happens? So this is methyl alcohol. It is not the alpha carbon. It is functional group attached carbon. The functional group attached adjacent carbon is called alpha carbon. This is functional group carbon. Attached carbon is called alpha carbon. The alpha methyl group in an alcoholic functional group also will participate in haloform reaction, but it is not participate. Now in this case what happens? This is a functional group carbon. It is adjacent to the functional group carbon, but it is not the methyl group, so not participate. Here this is a functional group attached carbon, adjacent carbon is having the methyl group, here also methyl group, so participate in haloform reaction. Now in this case you see, so it is functional group carbon which is attached with methyl group here, so it participate in iodoform reaction, that is haloform reaction. Now in this case this is alpha carbon, this is also carbon, alpha carbon, but no alpha methyl group, not participate. It is also alpha carbon, so it is not the CH3 functional group, CH3 group, so it will not participate in alpha methyl group. Is that clear? So that is what haloform reaction, which is very important. Is that clear? We will see the reaction mechanism. So what is the rate of reaction? So how it will react with alcoholic solutions also we will see. Now you see here how alcohol will react with iodine in presence of alkali. We will discuss here. This alcohol react with 4 moles of iodine, 4 moles of iodine in presence of sodium hydroxide. Then what happens? This methyl group CH3 group is completely oxidized to CHI3. Now here iodine when react with sodium hydroxide, it forms sodium hypoiodide, it will form. The sodium hypoiodide will act as strong oxidizing agent which oxidizes primary alcohol to aldehydes. That aldehyde on further reaction with this iodine will get the water iodoform, that is yellow crystalline solid will get. So now in this case what happens? Sodium formate we are getting, along with that 5 moles of sodium iodide plus 5 moles of water we are getting. Now in the same way, instead of taking here sodium hydroxide, we can take the sodium carbonate also. Sodium carbonate is also a base which is also can be taken. So for the oxidation of this ethyl alcohol to iodoform. Now ethyl alcohol react with iodine in presence of sodium carbonate, we are getting iodoform, yellow crystalline solid. Here what happens? Carbon dioxide will be released from this sodium carbonate. We are getting sodium salt of formic acid. So sodium iodide plus 3 moles of carbon dioxide plus 2 moles of water. That is the reaction with alcohols. Okay, na? So next we are going to see the mechanism of the reaction. Actually in haloform reaction, in carbonyl compound, what happens, what type of mechanism it takes place, that we are going to see now. Okay, so first we will see the mechanism. Now normal reaction I will write here, haloform reaction. I am taking aldehyde CH3C double bond O H. When it is react with the sodium hydroxide, when it is react with iodine in presence of sodium hydroxide, we are going to get CHI3 plus HC double bond O, ONA we are getting. So along with this we are getting sodium iodide plus water we are getting. So how many moles? 3 moles. 3 moles of sodium iodide. So sodium hydroxide should be, this iodine should be taken in 3 moles, that is I3 plus 3 iodines, 6 iodine. So 4 moles of sodium hydroxide. Here 1 sodium, here 3 sodium, total 4 sodiums plus 3 moles of water. That is actual reaction which takes place in iodoform reaction. What is the mechanism actually? You see, this is haloform reaction. This alpha carbon containing hydrogens are more acidic one. So one of the hydrogen from this aldehyde will be captured by this sodium hydroxide. Okay, now base OH minus ion captures the only H plus ions. What? Only H plus ion it will capture. This bond will be shifted onto this CH2. We'll get CH2 minus. Now this is what? Keto form. So this keto form rearranges to enol we will get. Keto form is rearranges to enol. That is double bond O will be double bonded carbon. That is double bonded carbon is attached with alcoholic group. That is called what? Enol. How you are getting? The negative charge will be shifted in between these two. The pi bond of carbonyl carbon will be shifted onto the oxygen because oxygen is more electronegative. So we are getting enol. So here what happens? We are adding the iodine. This iodine contains, so two iodine atom, one will be positive charge, one will be negative charge. Now in this case, this negative charge will come here. The pi bond is shifted onto this CH2. This CH2 get the negative charge. This negative charge is bonded to this iodine. This bond is shifted onto this iodine. Then this iodine get the negative charge. This I plus will be bonded onto to this CH2 group. Then we are getting CH2I plus C double bond O H. Now here what happens? In this case what happens? Here one water molecule is lost. One water molecule, that is one H plus ion, one OH minus ion, one water molecule, 1 mole of sodium hydroxide we used, and 1 mole of iodine is completed till now here. Now again we have the 2 more alpha hydrogens. So one more time we have to add the sodium hydroxide. We will get the water which captures the only proton. The bond will be shifted onto that CH carbon. So here OH minus ion which lost the 1 more water molecule. So we are getting this compound which is a keto form. Again this negative charge shifted. This pi bond is shifted onto this oxygen. We are going to get this compound. Okay now. So this is a keto compound. These two are rearrangement reaction. Now again what happens? 1 more mole of iodine. So this iodine contains 2 iodine atoms. Now in this case what happens? Here whatever the bond which is shifted here, this pi bond is shifted onto this carbon. Now here negative charge is there. This negative charge will come to this iodine. So this bond is shifted onto this iodine. I minus will combine with here sodium plus. Na plus ions are left over now. That Na plus ions combined. Here also the I plus which is combined, I minus which is combined with Na plus ion. 2 sodium iodides are left over till now here. Okay. So one more iodine is required. Iodine is combined. Now here this carbon is alpha carbon, again has the 1 more alpha hydrogen. So that alpha hydrogen again react with sodium hydroxide. So we are getting this compound, this negative charge again shifted. So we will get this compound. Again what happens? So this negative charge will be shifted. This pi bond is shifted onto this carbon. That negative charge is attacked on this iodine. We are getting I minus. Okay. So here what? I minus and Na plus ions here. The Na plus ion here water molecule is lost now. So Na plus ion, this I minus, again it is lost as sodium iodide. Now we are getting the water, this compound. This is Ci3 C double bond OH. Now again here OH minus ion is there. This OH minus ion is attacked on this carbonyl carbon. So this oxygen get the negative charge. Okay. So then what happens? Whenever this negative charge is shifted here, among now this Ci3 is there and OH is there. Which is the better nucleophile? Which is the better living one? This carbonyl carbon with this carbon with a 3 iodine group is very easily leaves this compound. Is that clear? So we are getting Ci3 minus we are getting. That is this bond completely shifted onto this one. Now we are getting the formic acid. Now this formic acid is the strongest acid. So which releases the H plus ion. That H plus ions are taken by this Ci3 minus. Okay now. So then what happens? We are getting O minus. This bond is shifted. O minus. Now whatever the sodium ion which is left over, no, that sodium ion will be combined with this COO minus. That is sodium salt of formic acid plus iodoform we are getting. Is that clear? Now we will see here the rate of reaction will be there. No? the rate of reaction mainly depends on the base. The rate mainly depends on the rate is directly proportional to concentration of base as well as the number of alpha hydrogen containing carbonyl compound, that is CH3 C double bond OH. So it is a second order kinetic which depends on the water concentration of base. Okay now. So now I will give you a simple example here. So this is an acetaldehyde which is on reaction with different halogens. Now you see here chlorine react in presence of sodium hydroxide. So bromine react in presence of sodium hydroxide. So if it is iodine react in presence of sodium hydroxide. So what happens? The rate of reaction here, the rate will be R1. Here rate is R2. So in this case rate is R3. Which rate is highest one? R1, R2, R3. Which is the highest rate here? That R1 or R2 or R3? All the rates are equal. R1 is equal to R2 is equal to R3. What is the reason here? The rate of reaction does not depend on the type of halogen. It depends only on the what concentration of base which we are using. Here base is same. So rate of reaction will be remains same. By changing halogen, rate of reaction will not changes because rate depends on the what concentration of halide as well as the concentration of aldehyde or carbonyl carbon which is having methyl ketone, methyl group, carbonyl carbon with methyl group. So that is the rate of reaction. It is a second order reaction. Is that clear? So that is the rate of reaction is mainly depends on the water attacking of the base on the carbonyl carbon, which does not depend on the water type of halogen which are present. Is that clear? So that is rate of reaction. We'll see some more example. Haloform reaction, some other reagent we are using here. So here halogen when react with the dilute sodium hydroxide, what happens? We are getting sodium halide and sodium hypohalide. This sodium hypohalide is used as oxidizing agent, which is used as oxidizing agent, which oxidizes easily and forms the water iodoform or haloform it will be. If it is sodium hypoiodide react with this acetaldehyde, we are going to get iodoform plus HC double bond ONA, sodium salt of formic acid we are getting. So similarly acetone, this is we have the water carbonyl carbon, adjacent carbon will be water methyl group. So that is oxidized to iodoform plus HC double bond CH3 C double bond ONA we are getting. That is sodium acetate we are getting because here CH3 group is there. Now here chlorine no, so we will get the chloroform CHCl3. So that is in case of carbonyl compound with sodium hypochlorite. Now we will use the bleaching powder as also as used as haloform agent. Now how you will get the bleaching powder? When lime water, this is what calcium hydroxide is called water, lime water. So it is also called milk of lime also. That lime water react with chlorine gas. That chlorine is oxidizes lime water to calcium oxychloride. This calcium oxychloride is called bleaching powder. Bleaching powder. This bleaching powder will also act as oxidizing agent, which act as oxidizing agent. So this oxidizes the aldehydes and ketones which contains the alpha methyl group into haloform. Now we are getting haloform CHCl3. Along with that we are getting the calcium formate we are getting, that is CaHC double bond O taken twice we are getting, that is calcium formate we are getting. So next here acetone when react with calcium oxychloride, that is bleaching powder, we are getting haloform, that is chloroform plus calcium acetate we are getting CH3 COO taken twice, that is calcium acetate we are getting. Now you see, observe these two reactions. What is the difference you are observing upon heating? That is, it is also called dry distillation. Whenever we are doing the dry distillation, so what happens you see in this case, which is somewhat important reaction. First we will get the chloroform. that is CHCl3, along with that calcium acetate we are getting CH3COO taken twice. This is calcium acetate. Now you see this is a calcium acetate, O, C double bond O, CH3, O, C double bond O, CH3. Now in this case what happens? This calcium acetate upon heating, dry distillation, that is in absence of water, we are doing the water distillation process. Whenever we are heating, then what happens? It will be removed as what? Calcium carbonate. Now CO3, CaCO3 will be lost. CaCO3 plus what is left over? We have CH3 and C double bond O, CH3. That is we are getting again ketone we are getting. Again we are going to get the ketone. So similarly this calcium formate on dry distillation we are getting the again that methyl formate will get. Is that clear? So that is very important one. Next, after that, alcohols when react with this sodium hypohalide, it is also haloform reagent. What are the haloform reagent we are using? Halogen in presence of sodium hydroxide, halogen in presence of sodium carbonate, sodium hypohalides we are using, and bleaching powder is also used. Now in this case it is a alcoholic carbon, it is attached with CH3 groups to participate in haloform reaction. The CH3 changes to iodoform. Now here sodium hypoiodide is there, CHI3 plus here first actually what happens, this is an oxidizing agent now which oxidizes this primary alcohol to aldehyde. Primary alcohols are oxidized to aldehyde by this sodium hypoiodide, which is on further reaction with the sodium hypoiodide. Then what happens? We are going to get the iodoform. We are going to get the iodoform. Now we are going to get the iodoform, that is CHI3 plus HC double bond O, ONA. Is that clear? So similarly you take this methyl alcohol. Will that methyl alcohol participate in iodoform reaction? No, because the functional group is this one. Functional group attached carbon is this one. It should be attached with adjacent carbon should be methyl group, but it is not having that one. Here also functional group adjacent carbon is CH2, which not participate in haloform reaction. In this case you see here, this is a functional group carbon, adjacent carbons are methyl groups. So this secondary alcohol first oxidizes to ketone. Secondary alcohol what happens? First oxidizes to ketone. You see here we are getting initially ketone, C double bond O, CH3. This ketone on further reaction with the sodium hypoiodide, then we are going to get iodoform plus we are getting the CH3COONA, sodium acetate we are getting. Is that clear? So because carbonyl carbon, adjacent carbon is what? CH3. So definitely it will participate in haloform reaction. We had seen the mechanism also. Is that clear? So how the alcohols also reacted we had seen. Now we will see some exceptional cases. Even though they contain carbonyl methyl group, carbonyl carbon adjacent methyl group, some will not participate in haloform reaction. Now you see in this case, this reaction is participate in haloform reaction. We had seen the mechanism. One of the intermediate product in that mechanism will get this one. So it participate in haloform reaction. Here also it is also what? One of the intermediate product in haloform reaction, which is also participate in haloform reaction. Here also it is also an intermediate product which is also participate. This is carbonyl carbon adjacent we have CH3, so participate in haloform reaction. It is also participate here CHBr2, which is one of the intermediate product in the mechanism. So mechanism we had explained. So once you watch that mechanism, then you will understand. Now in this case, you see here we have CH3 carbon is there, but carbonyl carbon adjacent CH3 is there. It should participate in haloform reaction. But what happens, you know, now this carbon containing hydrogens are not more acidic when compared to this carbon. Okay, now this carbon containing hydrogens are more acidic. These are more acidic hydrogens when compared to this carbon. Okay, now when compared to this carbon containing hydrogens are more acidic because it is directly bonded with what? Electron withdrawing carbon. So whenever it react with sodium hydroxide, so we are going to get CH3, C double bond O. Here CH, one of the hydrogen is lost as H plus ion. We'll get CH minus N double bond O, O minus we are getting. Okay now. Now in this case, this negative charge is there. No, this negative charge is distributed in both the direction. Now this direction as well as this negative charge is distributed in this direction also. That is, this negative charge is distributing with this electron withdrawing group as well as this carbonyl carbon. Then that negative charge is decreased means which is not attack on the iodine. Okay now, which is not attack on the iodine and it will not form the iodomethane. Okay now, so that is it is not possible. So in this case, even though which contains the methyl group, carbonyl methyl group, but it not participate in haloform reaction. It is also same. So it is more acidic one. It is an electron withdrawing group. So which stabilize this molecule itself with resonance. So it is not takes place further reaction, which is also not participate, even though which contains carbonyl methyl group. Okay na? So keto methyl group is present. Here also you see here keto methyl group is there. Here also keto methyl group is there. So now here this methyl group is more acidic or this carbon containing hydrogens are more acidic one? This carbon containing hydrogens are more acidic. What is the reason here? It is also called methylene carbon because both are what? Electron withdrawing group. In between electron withdrawing group, whatever the hydrogens are there, those hydrogens are more acidic. When it is react with sodium hydroxide, 2 moles of sodium hydroxide and 2 moles of iodine, we are going to get CH3, C double bond O, Ci2, C double bond O, CH3 will get. Because the 2 hydrogens are replaced by 2 moles of OH minus ion, last dash 2 moles of water. Now which is again react with OH minus ion, that is sodium hydroxide. This OH minus ion is attacked here. This carbon get the negative charge. Then we are getting CH3, C double bond O, OH. Along with that, C minus I2, C double bond O, CH3 we are getting. Which is on further reaction with iodine, we are getting CI3, C double bond O, CH3 we are getting. Which is again react with OH minus ion. So then what happens? Again we will get CI3 minus plus OH, C double bond O, CH3 we are getting. This H plus ion combined with this hydrogen and this react with the sodium ion and we will get the sodium acetate. That is the actual reaction takes place. Now here this carbonyl methyl group is not involving in haloform reaction. Which is involving? Methylene carbon is involving. That is what the carbonyl carbon, in between the carbon is called what? Methylene carbon. That carbon containing hydrogens are more acidic, which is very, very important one. Now here also what happened? This carbon participate in haloform reaction, which also, this is also participate because both are electron withdrawing group. Now in this case you see this is what alcoholic carbon. Alcoholic carbon, adjacent carbon is what? CH3. So which participate in haloform reaction. Now in this case, this is the compound. Now this compound is very important. Here it is, we have the what? CH2 group. Here there is no CH3. Carbonyl methyl group is not there. C double bond O, CH3 group is not there. But even though it participate in haloform reaction, because the haloform reaction participated by this carbon, because this carbon containing 2 hydrogens are more acidic. It is a methylene carbon which is present between the 2 carbonyl carbon, which is very, very important one. Now in this case you see these two are what? OCH3 and OCS3, electron releasing group. What happens actually? So when compared to the whatever the Ci3 minus, this OCH3 is the better living one. So for that reason it is also not participate in haloform reaction. And also this electron releasing group, what they will do? They decreases the acidic strength of this hydrogen which is present on the methylene carbon. Electron releasing group decreases acidic strength. So which does not take place in haloform reaction. This is what complete haloform reaction you never find in one book. So complete haloform reaction we will see in some will be in alcohol, some will be in carbonyl compound, So you will not see all type of exceptional reactions and different types of example. I hope so you have enjoyed this haloform reaction. Thank you. Have a nice day. Keep watching Appa Chemistry classes.